Today, we're going to talk about the remote-controlled smart bobber. Our advisors are Dr. Karkhanis and Dr. Gonzalez. Our team members are Tanvir, Afridi, MD, Waliur, Farzana, and Fairooz. In our project, we want to design a remote-controlled robotic bobber. We want to integrate propellers and different sensors that will allow the bobber to safely navigate the water. Lastly, we want to develop more features that will help users achieve higher success in catching fish.
Why is the design important? The design is one of the key elements for the floatability of the bobber. Our design features are here to make fishing much easier and fun. We also show that a recreational activity like fishing could be advanced using technology. And most importantly, we encourage eco-friendliness.
Some of the problems that we face with a regular bobber is that it might get stuck to another bobber or logs floating in the water. This might lead to the fisherman cutting the wire off, which leads to the hook to go to the bed of the ocean. This is bad for marine life as it can hurt the corals, fishes, and get stuck in the swimmer's foot. Luckily, we have a solution.
A remote control bobber will solve these problems. This would solve the casting issue by allowing the user to manually control the bobber, which would fix the casting. This manual control method would also cause the hook to have a much lower chance of getting stuck on a rock or an object since the user can control it to avoid them. This project also has many engineering constraints and user requirements. The parts and materials must be cost efficient and the bobber must also be environmentally flexible. It must also float and it must have a good power supply and energy source. It also must be controlled by a remote control device. Finally, the remote controlled robotic bobber must follow DEP water regulations and DEC fishing regulations.
Bernoulli's principle is one of our key principles. As it explains here, there will be low pressure inside the bobber where water will be pushing to get in, and the higher pressure beneath the bobber will have a force which will pass starting below the surface to the top of the bobber. This will allow the bobber to float steadily on water surface as the image to the right presents.
In the Arduino code, we have switches that control the direction of the motor. First, in the code, we have to initialize and then we have to set the instructions. The switches control the directions. The first switch moves to the 180-degree position when pressed and waits for 1 second. The other switches do the same thing, but the rotation is different. Like the second switch moves to the 90-degree position and the third switch to the 0-degree position.
This is for forward. This is for turning right. This is for turning back, reversing this way.
In this slide, we have a couple of prototype sketches of our design. Our design consists of a servo motor to change the direction of the bobber and a propeller motor to propel the bobber forward. On the top left, we have an instrumentation diagram where you can see we need 2 motors, microcontroller, battery, antenna, and a remote controller for our design to work. In the center, we have a rough prototype where we have a servo motor that changes the direction of the propeller motor so the propeller motor can propel forward. In the future, we plan to do more remote controller testing to Arduino microcontroller, continue to work on Bernoulli's principle. These iterations will allow us to move forward to make the design a success.
Bernoulli's principle was learned through floatability. We'll be using a radio frequency technology instead of IR technology since it is more beneficial for our project. Radio frequency has a longer range and can deal with simple commands. It has a higher energy transfer efficiency, shorter process time, instant and accurate process control. Movement may require certain types of motors. Depending on the type of motor chosen, we will determine if the bobber can withstand temperatures between the ranges of -20 degrees to 40 degrees Celsius. Visualizing the prototype makes it easier to understand the weight distribution of the product. Different designs have unique advantages, such as radio frequency technology that we'll be using for this project. Simulating the flotation of the device makes calculations easier to follow and understand. Some calculations are FE calculations, fluid flow, fluid dynamics, properties such as fluid viscosity, velocity, and pressure.
For the spring semester, we want to start off by ordering parts, 3D printing the prototype, and assembling the bobber. We want to refine the programming and RF radio part of the bobber to be controlled via remote control. Following that, we want to test our prototype and test for problems such as water getting into the bobber and direction control. Then we want to fine-tune the problem and fix the problems. Finally, we want to make the presentation board and do the final presentation at the Senior Design Expo. Thank you for your time from Team 3.